Good day, students. I'm here again on this platform to study more of probability. The other time we discussed on probability and we had definition. And the definition, we said that probability of finding an event is that you always have your required outcome divided by the possible outcome. Always remember that. And in probability, when you are studying probability, you will be coming across some terms that are very important that will lead you on what to do. Like some of them are here. We have or, and, replacement, without replacement. So if you have that, when you come across any one of them, it is telling you the direction of what you will do in solving that problem of probability. Now let's pick the first one, or. Or, this is a term used when a specific event that happened is not mentioned. It means there is that tendency of others to occur or happen. This involves addition in probability. When you have this or that happen, they are asking you to add those probabilities. It means you have to look at the probability of the individual and then you put them together. For instance, if A, B, and C are involved, then the probability of picking one of them may be A or B. B, A or C. C, it could be A or B or C. So any one of them can be asked, since there is not any specific one that is asked. But if they only say A, then you now reflect to the lesson we did the other time. We depend on only one pick, and the one was mentioned. But this one is mentioned, it could be this or that, like what we have them here. Now, like the A, let's solve this question. Solution to this question now. For the A, we know that we have three events. We have A, B, and C. We have three of them. Now, we know that our formula is giving us the required outcome and the possible outcome. So you will always have your required outcome divided by the possible outcome. The required outcome is the item you have that has happened. And then the possible outcome is the total number of the events that are involved. So we have the total number of the events are 1, 2, 3, which is A, B, and C. So for us to calculate the A, which is the A or B, is that first of all, the probability of A is the same thing as we have only one A. So it will be 1 over the total number of them, 1, 2, 3, 1 over 3. And the probability of B is also only one B appearing. So we have 1 over, the possible outcome is also 3. So for having A or B now, you now add, I say O is for addition. So it means that probability of A or B is equal to, you now add our 1 over 3 plus 1 over 3. From your fraction, addition of fractions from your primary school, you find out that when they have the same denominator, just add the numerator over one of the denominator. So we have 1 plus 1, which we're now going to have 2 over 3, because they have the same denominator. But you can go for the Lcm method. The LCM method, if you have forgotten, let's recall ourselves for this one, but we will not do for other ones. So, if you have 1/3 plus 1/3, your LCM now. Since both of them can divide each other, so we still have 3 as our LCM. But you can equally look for the LCM by multiplying the denominators, can give you another LCM, which will have 3 times 3. Another LCM would be 9. You will still arrive at the same answer. So for this one now, we have 3 divided by 3. We have 1. 1 times 1, we have 1. Plus 3 divided by 3, we have 1. 1 times 1, we have 1. Then we have 1 plus 1, we have what? 2/3, which we have got the same result with the one we did by saying just add the numerators, since they have the same denominators. Then for B, we have A or B. We have A or B. So we have B, A or B. So the A or B, we know that our probability of A is 1/3. Probability of A or C. Probability of C is 1/3 too, because we have only one C in the possible numbers. So we now have the same thing as our probability of A or C will be 1/3 plus 1/3, which will also give us the same thing as 2/3. Okay? And the same thing for the third one, where we have the probability of A or B or C is the same thing as our C. It will be our probability of A, which we know that is 1/3, probability of B, which is 1/3, probability of C, which is 1/3. It will be the same thing as having it as probability of A or B or C is called 1/3 plus 1/3 plus 1/3. So if you have this one, they still have the same denominators. So you just add the numerators, which will give you 3/3. And if you have 3/3, what do you have? You have 1. So the answer will be 1 for these 3 of them. Okay? Now, we have seen for O. It happens to any other event. If you have, for instance, if you have this one, let's do this one practically now. You have these tops. The top, we have what we call up. This is the up. The inside will show up, and then the back will now show up. This one is down. This one is down, while this one is up. So if I have the 2 of them, okay, then we are using only one out of the 2. This one, anyone can happen. If I throw it, I will not mention whether which one. If I throw it like this, it is the down that has shown. This one is specific. This one is specific. It is the down that we have shown. So the down has shown up. Okay? The down has shown up. Where we will now have 2 of them, the up and down. We're having only 2 issues on this particular topic. So already it is the down that has shown up. So we are going to have 1 all over the 2 events, which is the up and down. There are 2. It's 1/2. But if I said this top now, I will ask you, what is the probability of throwing a counter? This, we call it a counter. Okay? So what is the probability of throwing a counter, and the probability is either up or down, I will say calculate. Calculate the probability that it is up or down. Then it will be my up, I know, is equal to 1/2. Okay? And then my down is equal to also 1/2. So the probability of up or down will be 1/2 plus 1/2. Okay? So if you add this one, you still have what? 2/2, which will give you your 1 whole number. And many others like this, many other things like that. You continue with them in that order. Okay? Now, in a die too, the same thing. They can say that or that. You know that the two events you are adding their probability. And that is all about what we talk about, or in probability. Then the next one is the and in probability. This and involves more than one event at a time, at the same time. Okay? So this is a term used when two or more events happen at a time. This one involves multiplication in probability. So if two things are happening at the same time, okay, then you will now look for their probability by multiplying their individual probability. For instance, if A, B, C are involved in a particular issue, then the probability of picking two of them at the same time may be A and B, B and C, C and A, okay? It may be A and A, it may be C and C, it may be B and B, all the same. Just know their individual probability, then you multiply them. Let's see how we can solve these ones now. Okay? So for solution for this issue, A, that we should find if we are involved with A, B, C. We know that the event, we have three of them, A, B, and C. There are three of them. Now the probability of getting an A and B, we know that our A will be 1/3. B will be 1/3. Then the probability of getting A and B will be equal to 1/3 times 1/3. Okay? So if you have that in multiplication, you can temper with them. If there's a cross division, if there's the numerator, one of the numerator is having a common factor with one of the denominator, you can cross divide. But for this one, there's no any common factor. So you just multiply the numerators, multiply the denominators, and you are done. So for this one, you are going to have 1 times 1/3 times 3, which will give you 1/9. So this is the probability of picking an A and a B. Okay? B, probability of picking a B and a C. We now have that probability of picking a B and a C will be equal to, we know that our probability of our B is 1/3. Then times the probability of picking or getting C, we know that C is also 1/3. So we have 1/3. So we are now going to have, this one is now equal to, since they don't have any common thing to reduce it to a simpler fraction, we'll now have 1 times 1 is 1 over 3 times 3 is 9. And you are done with that. So I will leave the last one, do it on your own. Do that one on your own. Okay? So we will now look at, for instance, I want us to, on this note, for instance, if you have 3 of them, like this stops, it's the same thing. Let me throw all of them and see what will happen. You can see that we have 2 ups and 1 down. We have 2 ups and 1 down. So it means that if you have 1 down, the down is equal to 1 over 3 of them. And then the ups are 2. So it will be 2 over 3. Okay? So it means we have down, comma, up, comma, up. That is how the question would be. Down, comma, up, comma, up. Up and up. I will say up and up. Because we are treating and. So it means that we are going to have the probability of down times the probability of up times the probability of another up. And there are 3 in number. So all we know is that this one will be 1 over 3 times 1 over 3 times 1 over 3. So if you have this one, the issue of 2 over this one, we are treating them individually, so the ups will be 1 over 3 and 1 over 3. So if you have that, you multiply all of them. This one now will give you 1 times 1 times 1, you are going to have 1 over 3 times 3 times 3, you are going to have 27. So the probability of getting down, comma, up, and up will be 1 over 27. So just as I told you, we have seen the other terms. The other next one is with replacement. With replacement means you pick and you replace. That is, this is when one picks an item and return it where it was. For instance, that is example number 1. What is the probability that 2 cards are picked from a pack of 54 cards, one after the other with replacement? So if you have the cards now, this is the pack of the cards. You pick one after the other, you not pick them at the same time. Okay? So first of all, the first picking, so solution to this question now. Number 1. So first picking, we know that if you pick one, already we know the complete pack is 54 of them inside. So you are going to pick one. So this is one card I've picked. So we are going to have 1 all over 54. So we have 1 all over 54. The second picking, you have to, since they say with replacement, you have to replace it first before you pick another one. I've replaced it. So I will pick another one again. So I'll pick another one. The second one is now 1 over 54. It will not change it because you have returned it, they are still the 54. When you pick, it's still 1 over 54. Okay? We'll come and see another one later. But for this one now, we have 1 over 54, 1 over 54. So if it were all, you add them. If it is this and that, you multiply them. Okay? So this one, there's nothing that is mentioned. Anyone in work, you are right, because they didn't say O to them. So for this one, we now say probability of picking 1 and 1 is equal to 1 over 54 times 1 over 54, which we will have 1 times 1 is 1 all over 54 times 54. And this one you have it as 1 over, you do your traditional multiplication. In our JS1, remember, we did 3 methods of multiplying numbers. We did box method, we did Napier method, we did traditional method. So I'm going to use the traditional method to do the multiplication. So we have 54 times 54. So if we do this one, we're going to have 4 times 4, 16, we have 6 carry 1. 4 times 5, we have 20 plus 1, 21. 5 times 4, we have 20. We have 0, carry 2. 5 times 5, we have 25 plus 2. We have 27. Then you add. So we have 6, we have 1, we have 9, we have 2. So this probability will be 1 all over 29, 2,916. So this will be your probability for the picking of 2 cats from 54 packs. Now the second one is talking about counting sticks, that 3 counting sticks are picked from a pack of 50 counting sticks. Okay? Counting sticks. What is the probability that the 3 sticks are picked, one after the other, with replacement, not without, with replacement? Now, if you have this one, then you now have your pack of counting sticks. So this is my pack of counting sticks. There are 50. The other time we counted them, there was 50. Now, there are 3. So the first picking, you pick 1. So you pick 1. This is the pick 1. Don't bother about the color. Just we have picked 1 stick. Okay? So for the 1 stick, we are going to have 1 over 50. The second picking, you have to, before you pick the second one, you have to return the one you have picked to give us back the 50. So then you take the second picking. We are going to have also 1 over 50. Then the third picking, you have to return it back again. Return it back before picking 1 again. Picking 1 again. We have 1 over 50. So the probability of picking 1, probability of picking 1, 1 and 1, it will be equal to 1 all over 54. So 50, this one is 50, times 1 all over 50, times 1 all over 50, which will now give you 1 all over 50 times 50 times 50. The same traditional multiplication in our primary school, and I know you people too, they taught you. When you have numbers with zeros, there's a simple way it can help you to do it. So if you have 50, you are multiplied by another number that ends with 0. Just add the 0 to it like this. Then you multiply by 5. I'm picking the first 250. So now we have 0, we have 0, 5 times 5, we have 25. Then pick the third 50 times 50, you add the 0 to it, put your 5. Then you have 0, 0, 0, 5 times 5, you have 25, 5 carry 2. 5 times 2, 10, plus 2, you have 12. So you now have 1 all over 125,000. So this will be the probability of picking 3 counting sticks. Then, when you have that, the third one, let's see what will happen to the third one. The third one is, if a student chooses 2 bottles with replacement, what is the probability of what the person pick or picking? Please, class, put picking a Coke and a Sprite in that order. A Coke and a Sprite in that order. Now, this is a complete crate of minerals, because we are talking about bottles. So minerals deals with bottles. The complete crate of minerals has 24 bottles inside. Okay? So we have 24 bottles inside. Okay? So if this is the crate of minerals, and that, what is the probability of picking Coke and Sprite in that order? Okay? So let me pick Coke. This is a Coke. Okay? This is a Coke. Have you seen it? So, what is the probability of picking this Coke now? We have 1, I've picked 1 out of the crate. So it will be 1 over 24. But to me now, they have mentioned the name. Are you hearing me? They have mentioned the name. You have to count how many Cokes are there inside the crate, so that you will now know. So the Cokes here, they are about, we have 1, 2, 1, 2, this is the third one. So I will have 3 over 24, because there are 3, they have mentioned name. If they say just pick 1 bottle without name, I will now say it is 1 over 24. But now they have mentioned a brand. So it will be 3 over 24. So, number 3. So our Coke is equal to 3 over 24. Then I'll replace it back. They say with replacement, I'll replace it back. I'm still having 24. Then they say the other one is Sprite. So in this crate we have 1, 2, 3, 4 Sprites inside the crate. So we have 4 of them. So when I now pick one, it will be 4 over 24. So we have Sprite equals to 4 over 24. Okay? So picking that and that, 4 over 24. But look at this second one. We have 4 over 24. You can still reduce it to a simple fraction before you can do your calculation. So we reduce this one to simple. But if you don't want to reduce it now, let's go on first and see what we'll do. So now, my probability of Coke and Sprite will now be 3 over 24 times 4 over 24. If you like, I say you can do it without the reduction. You can reduce before, you still get the same result. Okay? So, this one you can say 3 times 4, you have 12 over. Then we have 24 times 24. which you will do the same thing with what we did with these ones. We did our traditional multiplication. So we now have 24 times 24. Let's see what we have. We have 16, carry 1. We have 4 times 2, 8, 9. We have 2 times that is 8. We have 8. 2 times 2, we have 4. We add. So we have 6. 9 plus 8, we have 17. And then we have 5. So we are going to have 12 over 5, 7, 6. And if you look at the numerator and the denominator, they are both even numbers. So you can now reduce them to a simple fraction. So 2 into this one, we have 6. 2 into this, we have 2. Remember 1. 2 into 18, we have 9, remainder 1. 2 into 16, we have 8. So over 296. If you have 296, you can still reduce it. We still have a common factor. So if you have this, 2 into 6, we have 3. 2 into 2, we have 1. 2 into 9, we have 4, remainder 1. 2 into 16, we have 8. So therefore, we now have 3 over 1, 4, 8. You can equally go further if 3 can go into both of them. Let's try and see. 3 into 14, we have 6, remainder 2. 3 into 28 cannot go. So leave it as it is. Okay, so our answer is what? 3 over 148. Okay? Now, it can happen with any other event like that. So you have to take note of the language they use in any given probability. If you don't understand the language, that is where you begin to fail. But if you understand the language very well, you will not have problem with this one. This one is always a simple question that will save your time in any exams. So we'll look at if it is without, what will happen. As I told you, that we'll look at when it is without replacement. We have seen how it is with replacement. Okay, so if we cannot replace, what happens? Let's see what will happen. Now, we are having these questions. That this is where one picks an item and it is not to return back to where it was. Okay? Now, the examples we are having is the same example I'm having, but the only change is without. Instead of with replacement, it's now without replacement. Okay? So solution to these same questions in a different way. So what is the probability that 2 cards are picked from a pack of 54 cards? One after the other without replacement. Now this is my cards. Okay? So if I am picking one now, I will pick one. Yes, I'll pick one card. My first picking is equal to 1 all over 54. Because we have said that all of them are 54 in the cards. Now, for the second picking, I will not return it back to the pack. I will put it aside. Now, what do you think? How many are left now? We are left with -1, which we are left with 53 instead of 54. So I will now pick the second card. So I'll pick the second card. Now for this one, it will be second picking. It will be 1 over 53. But if, assuming they mention the type of card you will pick, Like the other time, there were some that were 12, some were 9, some were 7, and so on like that. If that category that they are 7 and I pick one out of them, then it will be the total number of those types, which is 7 over 53. But it is not so. It's just say we should pick one card without specification. So that is why I have 1 over 53. Now, the probability now of picking first and second cards, it will now be 1 over 54 times 1 over 53. 1 over 54 times 1 over 50 over 54. We have 53. Okay? So this will now be my probability. But the other one was 1 over 54 times 1 over 54. This time around, I have picked one, I did not return it back. So it is now, the first one is 1 over 54. The second one, it will be less with 1. So it will be 1 over 53. So now, I will now have it as 1 over 54 times 53. Just our traditional multiplication, 5, 4 times 5, 3. So 3 times 4, we are having 12, 2 carry 1. 3 times 5, we have 15 plus 1, we have 16. 5 times 4, we have 20, we have 0 carry 2. 5 times 5, 25 plus 2, 27. So we have 2, we have 6, we have 8, and then we have 2. So we are going to have 1 all over 2,862. This will be your probability without replacement. Question 2. The question 2 says 3 counting sticks are picked from a pack of 50 counting sticks. What is the probability that the 3 sticks are picked one after the other without replacement? Okay? So for this one, you first of all list them as I listed them here. The first picking, so, well, this is my cards and my sticks. This is the pack of the sticks. We have said that there are 50 in this pack. And we will not consider their colors now. We want to take generally just we have 50 counting sticks inside this pack. Now my first picking is I will pick one from this pack. So when I pick one, any one I will pick. This is one stick I pick. So this one will be 1 over 50. My second picking, I will not return it back inside the pack. So I will not return it. So it means that I'm left with 49 sticks inside the pack. I will now pick my second stick. So my second stick will be 1 all over 49. Remember the other one was 1 over 50 because I returned it back. This one I didn't return. So it will be less with 1. So 1 over 49. I will not return. I will take it back. I'm left with 48 of them because I picked 2 without replacement. Now I will take my start stick, which I will now pick. Okay? So this one will now be 1 all over 48. So the probability of picking first, second, and third without replacement will be 1 over 50 times 1 over 49 times 1 over 48. Okay? That one will now give you your probability of picking 3 sticks without replacement. Now, the same, you will now multiply them out Using our traditional method, so we have 49. I've told you that if you have a number that ends with 0, you just pick the 0 and add and multiply by the other number. So if you have, let's pick 49 times 50, just add the 0 of the 50. Then multiply by 5. Just this is primary arithmetic. So we have 0, we have 5 times 9 is 45. We have 5, remember 4, carry 4. So 5 times 4, we have 20 plus 4, we have 24. Then you multiply it again by 48. This one there is no 0 at the end, so you have to put the 2. So we have 8 times 0, we have 8 and 0. 8 times 5, we have 40, we have 0, carry 4. 8 times 4, we have 32 plus 4, we have 36. Put 6, carry 3. 4 times 2, 8. 8 plus 3, we have 11. Okay? Sorry, else. We have 0, we have 20, 40, I think I'm right. 40 carry 4, this and 32 plus this 36, carry 3, this and this is 16, not 16 plus 3, 19, so we have 19. Then 4 times this we have 0, 4 times 5 we have 20, 0 carry 2, 4 times 4, 16 plus 2, 18, 8 carry 1, 4 times 2, 8 plus 1, we have 9. So we have 0, you add them. 0, 6, we have 9 plus 8, we have 17, carry 1, we have 10, we have 11. So our probability for this one will be 1 all over 117,600. And you can see that what I told you from the beginning of our first lesson in probability, that your probability will never be more than 1 or less than 0. And you can see that what we have been calculating, all of them are within the range. None is greater. If you get your answer greater than 1, I told you are on your own. It's not correct. Or you have a less number than 0. Maybe you have -1 or -0.1. You are on your own. The answer is not correct. It means you didn't interpret your question properly. Okay? Then the third one is 2 bottles without replacement. What is the probability of picking Coke and Sprite in that order? Okay? So we have number 3. So picking of a Coke, since they have specified the type of the Coke, of the Fanta, I would say, minerals, they have specified that it's Coke. Then you have to, first of all, the first picking is Coke. You have to look at your crate of minerals. How many Coke do you have? So here I have 1, 2, 3, 4. 1, 2, 3 is 3. 3 of them are Coke. So if we have 3, then for this one it will be 3 out of how many bottles inside the crate? We are supposed to have 24. Any crate that is more than that, that one is a new brand. I've never known that. So now we are going to have 3 over 24. My second picking, they say if I pick one of them, it's 3 over 24. And that without replacement. So let me take it aside. So we have taken the other one without, we are not replacing it where we picked it. So now, when we have removed 1 now, you know that we have left with 23 instead of 24. So for the second picking now, it will be with the picking is sprite. How many of the sprite? You have to count them first. So in this particular 5 of them. 5 of them. So it means we are going to have 5 over 23. Remember, we have removed 1. So 5 over 23. So it means that we are going to have our probability of getting a cup and a sprite is equal to 3 over 24 times 5 over 23. So if we have that one like this, then what we'll now do is you have 3 times 5 all over 24 times 23. The reason why we're having big numbers here is that they will specify the type. If those sticks were specified with their colors, we would have done the same thing. How many of the blues, how many of the red, like the other one we did. But they didn't specify. They said we should just pick one stick. This one they said, one bottle that it is a cup and a sprite. Okay? So that's why we have to put the total number of the cup over the total number of the whole thing inside the crate. And then the total number of the sprite over the total number of the whole bottles inside the cup and the crate. So we now have, this one is 15 all over 24 times 23, which we have to do our long division method, which we call it the traditional method. So we have 24 times 23. So if it were 0, 0 at the end, it would be very cheap for us to get this one. But all of them are significant figures. So we have 3 times 4, we have 12, 2 carry 1. 3 times 2, 6 plus 1, 7. 2 times 4, we have 8. 2 times 2, we have 4. Then you add. So we have 2. 7 plus 8, we have 15. Put 5, carry 1. Then we have add the 1. We have to add the 1 to 4. We have 5. So the answer will now be 15 all over 5, 5, 2. In this case, if there is any common factor, you reduce it to its simplest form. Let's see if 3 can go from both numerator and denominator. 3 into 15, let's see, is 5. 3 into 5, here we have 1, remainder 2. 3 into 25, we have 8, remainder 1. 3 into 12, we have 4. So we are going to have, our answer will be equal to 5 all over 184. To its simplest form. You can write the answer in decimal form. This one can be 0 point. So if you divide this one, just your calculator, you just punch 5 divided by this, you get 0 point something like that. Whether you write it in this form or in decimal form, you are correct. Okay? In this case, there's a more elaboration on this. Assuming the picking of the bottles, when you pick first one, maybe here in this question, they said cup and cup. They are the same. Cup and cup. You find out that the calculation will be, you pick first is cup. So the first one is cup, you have 3 over 24. The second picking is another cup again. What you will now do, you will know that we have 3 cups. The cup has been reduced in number, right? So it means you are going to have 2 all over 23. You are going to have 2 all over 23. Then you now do the same process as you have done them. Just order is vain. They can happen like that. The same thing. Even this one too. The sticks here that we have. If they depend on colors, you know that the other time we were having them in different number. The blue were in different number, the red were in different number, the yellow they were in different number. So if you are picking the same color, you find out that the next picking, the number of those colors will reduce by 1, and the total number will also reduce by 1. The same thing. It applies to any other event. Whether in the class, they will pick a student in your class, and they will ask you to calculate the probability of your class, so on. And that is why it is very important to learn this topic, because we use it in our day-to-day activities. So I will give you assignment to go and do. Thank you. So this is the assignment I told you I will give you. You answer them based on what we did, and then you send the answers through this number. This is my WhatsApp number. So when you send, or if you want more explanation, if you didn't understand, you can WhatsApp me some comments, or you call me if you want to hear my voice for any explanation. So thank you.